Good afternoon, everybody. Thanks for listening to the last presentation of the conference. Not fleeing for the airport, the first opportunity. So I guess just as a little bit of context, John Risson was the one who came to me about 6 months ago. Can everybody hear me okay?
No.
A bit of a struggle.
No worries. I feel like a school teacher standing here. Is that better? Okay. Yeah, so John Risson came to me about 6 months ago and said the conference was coming up, and he knew that I had a background that kind of straddled engineering and cyber security, and he sort of posed a question to me, did I think it'd be worthwhile putting a presentation together that sort of spoke about the nexus between system and security engineering. And I kind of thought about it, and I thought, well, it's actually pretty timely given the way most systems are headed nowadays. So really the purpose of today, I think, is just to pose a few questions, perhaps get people talking a little bit, thinking about how does security come together with systems engineering. And when John spoke to me, I was actually partway through an 18-month role as a chief engineer within Telstra, running a fairly large project. So it had kind of taken me away from cyber security. I had about 150 engineers working for me, which included about 15 systems engineers, and John actually came in and sort of worked with us for a while. So I had my eyes opened a little bit, and I guess reminded about what systems engineering can bring to a project. So it was pretty timely to try and bring that together with some of my thoughts around cybersecurity. So we'll kick off, and happy to take any questions as we go, or I'll certainly leave some time when we get to the end as well. Okay, so I guess firstly, just to provide a little bit of context, as the slide says, when we drive across a bridge or we fly in an aircraft, we're always pretty confident and have a reasonable expectation when we get to the other side of the bridge that it will still be standing and that we will have travelled safely from one side to the other. When we hop in an aeroplane, we have the same expectation, mostly, perhaps not as safe as the bridge, but we still think it's pretty good. When we take off in Brisbane tonight, I'm fairly confident I'll land in Canberra. But shouldn't we have the same expectation for all of our systems? So there's been some good work done by NIST. There's a new standard, which for those who are interested came out in November 16 last year, which is around system security engineering. If anybody wants to take it down, if you're looking for a read, it's actually titled SP 800-160 in the finest NIST naming convention, which tries to bring together the concept of trustworthy and secure. So we'll just talk about what that means as we go through, but just trying to reinforce that you can be secure but not trustworthy, and vice versa. So for those who haven't spent a lot of time in the world of cyber, I'll just step through this slide because it really does give some context in the world in which we live and we operate. So what's changed, I guess? Cyber security really came out of IT systems and networks. So anyone who's working in systems engineering 10 years ago probably didn't get a big exposure to it. And similarly, people working in IT systems, John and Telstra and serious carriers are probably an exception, didn't necessarily have a big exposure to systems engineering. But what we see today is connectedness. So no longer do we have a car that's just a car. A house is not just a house. So everything now is connected, and it needs to be connected, and there's a lot of business benefits to that, and we'll talk about some of those as we go through. But what it does is that it means cyber security now needs to be part of that engineering discipline. Building a car that runs reliably and safely is not enough. It also needs to think about how safe it is from interference, from hackers, from other issues that can arise. So those traditional boundaries have merged. Once upon a time, John spoke this morning about system of systems. You could really look at what you were building, and you could probably draw a boundary and say this is where my accountability start and finish. I'd argue that that's no longer the case, and we'll talk about that. But anyone who's building a system now, one of the biggest challenges, certainly in the telco space, is to work out which bits do I control. Machine learning, artificial intelligence, we'll talk about a little bit, but there's some really good companies who are specialising in that space. So if you're building a network or a system, you probably wouldn't go to the trouble of building your own capability. what you would probably do is leverage one of the cloud-based capabilities, which have a lot of really smart data analytics, a lot of good learning algorithms. But now your boundary is well and truly outside your fence line. So as a systems engineer, here's a big component of your system, which is probably quite critical, which now you don't really control, so it's part of your supply chain. We talk about a thing called the attack surface, which from a cyber point of view really talks about, as an attacker, what's your exposure? So there's things like obviously physical access, there's remote access, there's supply chain, there's users, probably the biggest virus that infects most IT systems. So the attack surface now it's really important to define that, because once again, like that engineering boundary, you can't necessarily see it, you can't necessarily touch it, you can't really draw a line around it, but you really need to know where it is. The attacks are getting a lot more sophisticated. I mean, it's been that way for many years. There's an ecosystem out there. There's people who specialise in compromising systems and making them available. There's people who do exploits that will get you onto a system. There's people who do exploits that will let you exploit the system. There's people who sell credit card details. There's people who sell large networks. There was a big denial of service attack last year, which was actually done, it was one of the first ones done through the Internet of Things. And somebody wired up a whole bunch of fridges and home devices and took down some fairly large telco networks by using them as an attack vector. Lateral movement and escalation. I don't know if people are familiar with the concepts, but lateral movement really talks about if I want to get into your home network, as a simple example, what I might do is compromise your fridge. You're going, okay, what do I care? Clive now knows the status of my fridge. My milk's a bit old, my shopping list is a bit strange. But from your fridge, I might move laterally across into your home computer because it's on the same wireless network. Now I've got access to all your personal information, and if you're running a home business, your business information. And from your computer, I can move to your colleagues in your sort of business context. So that's the concept of lateral movement. Come in through the weakest spot and then use that to get to where you really want to be. For a sophisticated attacker, that can be quite a long duration. So it could be a 6-month exercise, it could be a 12-month exercise. It could be a smash and grab, sort of in today, there for 24 hours, gone tomorrow. But what it means, once again, from a systems point of view, is where is the boundary? Where is your sort of softest point? And the risks and the consequences are changing. There's some good statistics out there for anyone who works in cyber about what the cost of a breach is. I was talking to somebody in industry last week who had the misadventure of having their corporate system compromised. Happened about 6 months ago. He now knows that for him, it costs about $100,000 to fix every 100 megabytes of email data that he loses. In his case, he lost several hundred gigabytes. So it was a fairly large bill. By the time he got lawyers involved to speak to all the customers, let them know their personal information had been compromised. By the time he got specialists in to clean up his network, by the time he sort of put in place better security for next time. There was, I think everyone may have seen Equifax in the press over the last month, a big company in the US, probably one of their biggest companies with credit reference information. Cost the CEO his job, cost the company probably $300 or $400 million in lost earnings and potentially an ongoing cost. So the financial costs are fairly well understood. Reputational costs, people kind of understand. I think everybody wants to be known as a secure company, not an insecure company. We all know reputation is one of those things that's really hard to get, really easy to lose. But if we think about some of the new systems coming online, it's more than financial and it's more than reputational. We are really talking about people's safety and their health now, and we'll talk about that a little bit more with some of the examples. So the risks and the consequences, they are changing. We're not necessarily talking about white-collar crime with sort of white-collar consequences. We are now potentially talking about everyday people having some fairly bad experiences. So some of these trends are interesting, and I'm sure they've been touched on in some of the presentations. The machine learning and artificial intelligence is a really interesting one. It's pushing out everywhere, and I think what we're seeing is people specialising in that space and providing either an on-premises solution or a cloud-based solution. What are we talking about there? Well, autonomous vehicles, I know there was a session on that. Tesla, for example, fully instrument their vehicle, and as of May last year, they had 780 million miles worth of instrumentation data about driver behaviour, road behaviour, and they feed that back in a sort of feedback loop into their system design so that they can build a better car. And they're typically adding another 1 million hours of data every 10 hours. So they've got cars out there on the roads feeding it back. So the business benefit's fairly clear to see. Obviously the business risk is we've now got a fully sort of mobile wireless connected vehicle with a whole bunch of instrumentation control. So one of the themes you'll hear me talk about today really is security is all about business benefit versus risk. So it has a lot of similarities with systems engineering. I think systems engineering has to have that conversation with the business. It's probably a little easier sometimes to have that discussion. With security combined with engineering, sometimes it gets a little bit grey. What's the risk appetite for a business? If you're talking financial losses, it may sit at one point on the spectrum. If you're talking about an aircraft falling out of the sky or a medical disaster, then it's obviously a different risk conversation. Finance is interesting for AI. If you apply for loans with some banks now, you'll actually find that it's an algorithm that's making a decision on your credit worthiness. It's probably okay as long as the algorithm doesn't get compromised. Gets a little bit scarier with some of the hedge funds now are actually starting to trial some AI, doing things they call sensitivity analysis. So what they're typically doing is grabbing all the data from people's Facebook feeds, from news feeds, from everything that a stockbroker might normally do, because a lot of that hedge fund activity is driven by emotions and trends rather than real statistics. So they're experimenting with training an algorithm now to sort of make those split-second decisions and make those sort of millisecond trades. And that's great, but if you think back to the financial crisis, if those algorithms get it wrong, we're talking, huge impacts to people's lives and their economies. So if they're not well engineered, and if not engineered in a secure way, it has some really serious consequences. The transportation systems, there was an interesting instance, looking at Boeing and looking at Airbus, all those aircraft manufacturers, not sure there's people here who know it better than I do, are rolling out more and more sensors on their systems. So the Internet of Things with aircraft is, it's not just in the factories now. The factories are great because they can optimise the manufacturing, they can see what they're doing, they can do better stock control, better planning. But it's actually now starting to sort of be embedded in different parts of the aircraft. Now, if I was going to choose someone to make an aircraft, I would probably choose Boeing or Airbus. I wouldn't choose Microsoft or Google. But if I was going to choose someone to build my security around my Internet of Things, I'd probably choose Microsoft or Google. I probably wouldn't choose Boeing or Airbus. And that's nothing against any of those companies. It's just a sort of it's a culture and it's a natural fit. Some industries come from one direction, some come from another. Safety and quality of manufacturing, aircraft industry, cyber security, I tend to think more of the IT and the network industry. So how do we bring those people together? There was a fellow last year who ended up spending some time talking to the FBI because he demonstrated on a flight that by accessing the onboard entertainment system, he could actually do that lateral movement thing across to a network that actually ran some of the aircraft controls. Not a good thing, sitting there playing your Game Boy and potentially controlling an aircraft. As a network engineer, I can see what they got wrong. There's a concept called network segmentation that some people in the room might be well aware of, where you have trusted network segments and you make sure that things can't move between them. The people designing this part of the aircraft have violated that fairly fundamental principle from a security point of view, and the person was able to connect to the entertainment system and then move across to some more serious parts of the aircraft. If you look at, wearables and medical devices, people may have seen Dick Cheney when he was Vice President, had a pacemaker removed because he realised it had a wireless connection in it. And this gets back to that business risks and benefits discussion. It's great to have your pacemaker instrumented because you get a much better result. the medical support people know when your battery is starting to go flat. You don't have to sort of have more invasive checkups. They can optimise the way that it behaves, so you don't get that sort of unnecessary sort of zaps and interference, if you like, on your heart. But the downside is that it's got a wireless connection. So in August this year, one of the manufacturers in the US actually recalled 465,000 pacemakers because they had a wireless vulnerability. Now, when you think that's true, it's bad enough when you've got the inconvenience of taking your car back because you had a safety recall. Can you imagine booking in to see your cardio surgeon because you have to hand your pacemaker back? It's not the kind of thing that anybody wants to do, and it's not the kind of thing that any company wants to make people do. But they did a risk assessment, and given there have been published information about the vulnerabilities of this pacemaker, and what the vulnerabilities did was they allowed an attacker to either run the battery down faster than it should, or they allowed them to actually control it so that it would change its behaviour. So neither of those were really good outcomes. The other challenge with wearables and with Internet of Things is that they're all connected to other things. So if you get back to that point earlier about the weak point in your network, it's all part of that connectedness. On the automobiles, we've talked about that a little bit, but in 2015, Chrysler recalled 1.4 million Jeeps because hackers demonstrated they could take control and they drove them off the road, showed it at a hacker conference. There's a big hacker conference everywhere in the US called DEF CON, and every year for the last 4 years, they've had what they call the Car Village, and they've had people demonstrating a selection of vehicles that they can hack either remotely or via close access. So, once again, automotive manufacturers make really good cars. They've only really started thinking about the security part of that whole engineering cycle. So I guess this is actually one of the Telstra values that John will recognise. We have a thing we say better together, which basically means working better as a team. Now really, I think systems and security engineering can bring a lot of benefit to each other. They're both about more than the technical side, they're about the systems, the people and the processes. To be successful like systems engineering, it really is creating an integrated ecosystem. We've got a really clear partnership between the design teams, the operational teams, the build and the test teams, and with a really clear understanding built into the actual sort of right from the start of a project on how it all comes together. The third point, measure your progress and your outcomes, is sorry, can anyone hear me okay? Am I sort of echoing there or yep, all good? Measure your progress and your outcomes, make sure that you sort of understand how you can get better, and really take those lessons learned. So if you could sort of maybe think about those things as we go through, then we can sort of hopefully come back to some of those key messages. This is an extract from that NIST document. I won't go through it in detail, but the systems engineers in the room will recognise that what it's really saying is embed the security concepts in that system engineering cycle. And we'll talk about that as we go through, where it comes into the sort of requirements phase, the test phase, the build phase, the architecture phase. So this is just a model for people to think about, I guess. These are the 6 key things I'll quickly go through. So the development and delivery strategy, the alignment between systems engineering and security, where security fits in the requirements definition, the architecture and detailed design phases, testing and lifecycle management. So really close alignment with good system engineering practice. So when you're starting a project, think about your development model and your methodology. There's a bunch of security models on compliance requirements, test, what you need to do. They don't always have a good alignment with systems engineering models, so people in the room here I'm sure are quite au fait with ASDEFCON and some of those sort of defence models that sort of drive engineering outputs. With security, some have a better alignment than others. If you're working in the finance industry, there's some obvious nexus there, so set yourself up for success. If you're going to try and overlay security and system engineering, make sure you pick a square peg in a square hole. Don't try and sort of make a square peg fit in a round hole. Supply chain and sourcing, really important. Gets back to that earlier concept about your system engineering boundaries. If you're designing a system and for good reasons you have to choose machine learning that lives in a cloud, think about the security lens as well. Some clouds are more secure than others. Some vendors and suppliers have a better fit with the methodology that you might be trying to apply. Get the integration working between the program engineering operations and security teams. Security is not something that should be tacked on at the end. It should be like systems engineering right there from the start. Get the governance right, make security part of that whole roadmap. Cultural considerations. Security engineers, like systems engineers, have a reputation as thinking differently, perhaps acting differently. Make sure you bring those people together. You really can't underestimate the cultural considerations. Organisational model, make security like engineering part of the program team. Don't have them sitting off in an ivory tower casting judgment. They should be providing a solution, not just a scorecard. Think about the boundaries and accountabilities and responsibilities. So most people build systems with partners. It's not a game for individuals, so whether they're your key suppliers or whether they're your system integrators, make sure there's clear understanding. Security is not a single accountability. Like engineering, if there's a gap at the end of the project, to make sure that everybody knows how that gap got there. Don't have any sort of lack of clarity. Maturity. Some industries are more mature than others. I was talking to some colleagues last week about the legal industry, just as an example of an industry from a cyber security point of view that is starting to get more mature. They're now starting to realise that they can often be targeted because of the information they hold. They realise it hasn't been a priority for them, not in all cases. Once again, in the press last week, plastic surgeon over in London, pardon me, I don't know whether people saw that or not. It was disclosed that they had been compromised. Why a plastic surgeon? Well, it turns out they had some pretty interesting information about the royals, about some fairly famous celebrities. So the information they held is now being sort of used for blackmail purposes. So a lot of industries outside your typical banks and telcos and other people are now sort of growing into the space. Regulatory requirements. Different projects have different requirements. Once again, it's a maturity thing. If you're building a bridge, you probably have some pretty well understood industry standards. If you're building a bridge that's internet connected, not quite sure where you go for your standards for that one. So it's really thinking about what's the expectations. We've talked a little bit about the alignment between the suppliers, the partners and the customers. Also think about your standards and your processes. If you're doing an engineering program with a lot of software development, have you actually thought about secure coding practices rather than just good software engineering practices? We now have a team in Telstra doing what we call application security, and we've deliberately pushed out those people into all of our DevOps teams to make them part of the team so that we can try and grow that security coding culture. So we can mandate standards, we can mandate processes, but it's a mindset. Risk and threat assessments versus design management. So from a security point of view, we're expected to do a risk assessment based on the solution and the proposal, a threat assessment based on what we see. Are you a bank? What's your threat profile? Are you a medical provider? Are you a government agency? But then from a system engineering point of view, there's all those design management requirements too, so how do you bring those together? Security control framework, and we'll talk about that, needs to be built into your architecture. Security testing should be part of your overall test plan. So if you've got a verification and validation team doing a test plan, they might have a verification capability requirements matrix, a Vikram if they're working for defence. Link that across to your security testing. And build security management into your lifecycle management. Think about how it all comes together. Once again, this is another extract from that NIST standard. Really just shows that security requirements should just be part of your overall requirements definition. It's embedded in that cycle. It's not something that sort of sits off to the side. So requirements definition. what are your security policy frameworks? I think I heard Luke or someone say earlier, or might have been John, Defence Project might come out with 4,000 functional and performance specification requirements. If you're working in industry, you might have a smaller subset, but have you actually overlaid your security requirements? Do they align with your policy? Once again, the finance sector has some fairly good frameworks around security, so they need to be baked into the requirements for all their projects. Similarly with telcos, but it really does vary on industry by industry basis. But once you've got those requirements, one approach is to bake them into your system engineering requirements. So if you're running a sort of detailed requirements traceability model, an RTM, why not link your security requirements into your system and your subsystem specifications? I've seen that done. It works quite well. It gives you traceability through the whole project lifecycle. And also what happens is if any of your security requirements change, the government has a thing called the Information Security Manual, which ASD refreshes every year or two. When they bring out the next version of the ISM, you can go back and do an impact assessment and see the linkage between any security requirements back into your requirements baseline. So from a systems engineering point of view, run it as a sort of coherent approach rather than something that's sort of managed off to the side. And there's an example down the bottom, I guess, just of an ISM control, if people haven't read the ISM. It's 1,000 odd controls that you can read. But that one's around wireless networks. So if you're building a capability with a wireless network in, if you don't read the security controls until the end of your design phase, you're probably going to have to go back and change your design baseline. Governance. Security risks should be part of your overall design approach. Get them signed off at the same time, because security feeds back into your design. Last thing you want is a security stakeholder 3 months through the project refusing to sign off on a risk which puts you back into the design cycle. So the architecture really is where it all should come together. So the architecture really does need to reflect your security requirements. It sounds simple, it's not. Solution architecture documents and detailed designs should maintain that linkage. When you're doing a design study and a trade-off from an architecture point of view, security should be part of that. It's all about the risks and the costs and the benefits. Once again, the last thing you want is a team off to the side who are doing a security risk assessment and then coming in from a system engineering point of view and whacking you between the eyes 6 months later and going, you can't go forward because you've got to go backwards. So, the security team typically does a very detailed threat and risk assessment during the architecture and the design phase. So it should be overlaying all of your threats against your proposed architecture and your design and doing a really detailed risk assessment so that by the time you get the architecture signed off and get your detailed design signed off, you can be fairly confident that all the security requirements have been baked in. Think about your boundaries when you're doing your functional decomposition. From a security point of view, the risk assessment and ultimately the system accreditation typically draws accreditation boundaries. It works a lot better if they align with your functional architecture and your components. Typically, a wireless component of a solution would be a security boundary. It probably makes sense to have that part of your architectural boundary as well, and then you can sort of break it apart that way. It gets really messy if the security accreditation spans multiple sort of architectural boundaries, and it's really hard to sort of bring it together. This is kind of where the rubber hits the road, I guess, from a security point of view. Security really is about business risk, risk mitigation, risk tolerance, risk appetite. At the end of the day, as the project matures, there needs to be a constant conversation about the security risk map. I've seen projects where they start off, everything's red. By the end of the project, most is green with a few ambers for good reasons, because if it's got a dependency that you just can't sort of solve, then it'll be there and the stakeholders need to accept it. But as engineers and security professionals, we need to sort of explain why that risk can't be mitigated, why we need to carry it forward. But we just need to have a conversation, and it does come down to cost versus risk and consequences. I guess it's like an engineering discussion, but sometimes people are a little more flexible on security. I think there's a bigger history on things like flight safety where people understand, no, there's a point that you can't cross. With security, I think it's still more of a sort of dynamic conversation coming through. It's not very helpful if that gets rolled all the way through the system without a security assessment, especially if you've gone to a lot of trouble to build a secure capability and to demonstrate that. You then undo all that good work, so you've really got to make sure you've got that close alignment. With equipment upgrades, same issue. No point doing pen testing, making sure your solution's good, and then turning around and finding someone's done a product lifecycle upgrade and they haven't put it through all the other assessments you'd expect. But conversely, security can be a trigger for a change. There was a wireless vulnerability discussed a week or two ago, I think called a key replay attack, which had the nice acronym of the crack attack. When that happened, that highlighted some vulnerabilities and changes that were needed, so that had to flow back into the engineering change process. In that case, there were some emergency changes done. Within sort of 24 hours, 48 hours, vendors had patches, we had to get them in. But once again, that needs to go back in your configuration management baseline and be properly managed, so security can't be running rogue off to one site, madly patching things. Because just as important as engineering shouldn't break security shouldn't break engineering. The last thing you want is a design baseline that you lose control of because the security Nazis have been in there making changes. I think, Bill, that's about it. So we've got some time left for questions. If anybody has any questions, happy to take them.
So ask Michael to take the mic around, so if you could raise your hand, please, if you've got a question for Clive.
Thanks, mate. Great